Hello everyone. Assalamu alaikum warahmatullahi wabarakatuh and good afternoon. Thanks for being here with us today. Today we have a guest speech by the guest speaker, Dr. Khalid Muhammad Al-Mustafa. Dr. Khalid Al-Mustafa received his BS in Electrical Engineering, MS, and PhD in Wireless Communication from the University of Western Ontario, London, Ontario, Canada in 2003 and 2004 and 2007, respectively. He is currently working as an associate professor at Prince Sultan University in the Department of Information System at the College of Computer Science and Information Sciences, Riyadh, KSA. He served as a general supervisor for the Information Technology and Computer Services Center at PSU, chairman of the Department of Communication and Network Engineering, and the vice dean for the College of Engineering at PSU. He was the director of the Research and Initiative Center at PSU, as well as the CITO at PSU. His research interests include error performance evaluation of MIMO communication system in partially known channels, adaptive modulation and channel security, text recognition models, control systems with renewable energy application, data preprocessing, as well as machine learning and computer vision. Today, he is going to deliver the talk about the machine learning. It can't get any easier than this. We do believe it's a very interesting topic and it will be an insightful and knowledgeable session for you. Thank you so much, Dr. Khalid, for your time and for being here to deliver this insightful speech. So the floor is yours. Thank you.
Thank you, Dr. Tanzila. Jazakallah khair. And thanks to IDA Lab for giving me this opportunity to present this interesting talk. Assalamu alaikum, everyone. My name is Khalid. We will be presenting this in English, inshallah, for the many reasons. One of it, the actual machine learning topic. It's easier actually to present it in English at this stage. So let me share my screen so we don't spend a lot of time in the introduction, and then we'll try, inshallah, to go directly to the practical part of the presentation. So full screen. Oh, I'm sorry. I want to share my screen. Present now. Okay, so today's topic is, you guys see my screen? I want to make it small because we will be interchanging between the PowerPoint presentation and we will go later on to the actual solution that we will be using for the purpose of today's demo. So why I choose the title, it can't get any easier than this. Well, I am not a machine learning expert to start the discussion, but I have some moderate background about machine learning, and I have been working with it almost now 3 years. After just a quick chat with a colleague of mine, talking about what is machine learning, what is AI, how is it related to, and it is a heavy topic. I'm not going to say it is an easy topic. And I doubt most of us will have enough time to go in depth into a newly introduced topic for us to actually try to understand it and work on actually getting something publishable in that area. It's not easy, as you all know. And we all look for that one extra journal, one extra conference for various reasons. We don't want to go into details why we need that extra for the promotion, for the ranking, for your own enhancement of your own CV. So today's topic is actually can give you a head start on a very hot topic, which is machine learning, very condensed in terms of scientific background, but we will only see how can we actually just scratch the surface of what is machine learning and apply what we would know about what people will be looking for machine learning published papers, and then try to actually use a pre-designed tool for us, which is a very nicely done tool called WEKA. We will talk about it in a second. See how can that solution can help us actually derive certain result that research community in the machine learning, especially the bioinformatic area of machine learning, are interested to see. So we'll start right away. This is my email address, klmustafa@bsu.edu.sa. If you guys have any questions later on, you are welcome to send me an email and we can discuss it further. So we'll talk quickly about what is machine learning and what are the major algorithms that they are presented in common machine learning bioinformatic journal papers, that is, or even conferences. And since we are addressing machine learning or AI in general, obviously we are talking about data. And data, usually, it's categorized by certain statistical characteristics. And then we present some of them just to highlight the mean of some of these algorithms that we will be using for machine learning. Now, the parameter sensitivity and features of the available data, it will be clear more when we get to that point. And then we will introduce WEKA, and we'll try to have most of the rest of the time for an actual exercise. I will open my WEKA, open an actual data, and show you the how-to, okay? So we are not here to talk about why these algorithms work, why they give these results. No, it's just how they give these results, and it is up to you to actually interpret the result and compare it with other algorithms that you do on WEKA, and compare it with other literature to see the significance of your finding. Now, let us start with machine learning. Of course, machine learning is the concept of having a certain data that we would like to understand, get some information out of this data, and we try to do some sort of prediction of if we have a similar cases that is associated or related to this data, we can predict per se a certain outcome. So as a quick example, let us talk about maybe heart disease patients. So this is our example we will be doing as the practical example. So I have maybe 4,000 or 5,000 samples, different participants in the sample. Each one will have a different, we will have a set level of measurements that we will take from these samples. And these measurements are called features of my data or attribute of my data. So if I have 5,000, I'm not going to say patients because some of them will be positive heart disease patients. Some of them will be negative. That means they are healthy. So we will try to understand the data in the sense which one of these machine learning algorithms that we will introduce some of them now can, I'm going to use the word classify for now, can classify the data comparing to other possible machine learning algorithms. So I will pick one of these algorithms based on the accuracy of the classification that I will do on the data. And then I will run some statistical test on it as well, just to have a better sense of the, in terms of the errors, in terms of the area under curve, as we will discuss in a second, in terms of the maybe the kappa parameter, other statistical features that we are interested in to see how they are behaving. Now, let us say I have to do 25 different tests. So each test is one attribute or one feature for each sample. And at the end, I will say this sample is a patient or a positive has a heart disease, or a negative, it doesn't have heart disease, it's healthy. So why do I do all that? Okay, this might help the healthcare givers in the future to actually, if you have a certain walk-in, you don't have to do the whole 20 tests, as you will see in a minute. You might be able to predict if this patient or this sample or this person has a heart disease or not, maybe based on only 6 tests out of 20. So this is where we come into the actual feature selection, or the ranking of these features, or these tests, if you may call them, or attribute for my data, to be able to predict a certain case. Now, there are a lot of applications for machine learning. Actually, if I say unlimited, it will not be underestimation of machine learning. But the focus for today's presentation, or the focus that I've been working on for the last few years, is on bioinformatic um, application, because it is, I found it one of the easiest to actually get to know machine learning applications, or actually work on something that I can produce some good tangible results. Will be able to share it with the research community, as you will see in a minute. So machine learning is a very wide, again, is a very wide area. You have what's called supervised or unsupervised learning, the learning part of the machine learning naming. So supervised, if I have an output, I can point out this set of data, the output. So it is healthy heart disease patient, or a patient with heart disease. So I can know. So I can say it is either healthy or sick, or I can give it a binary representation and a 0 and a 1, or any other number for that matter. Or I can just say healthy or sick, H and S. So if I can do that, and now it is, as you can see, it's either sick or not sick, or healthy or not healthy. So that's what we use the classification part for. That's where the word classification keep appearing. So I classify a certain sample, if he or she healthy or not healthy. Now, this is just discrete. Now, sometimes I have more than one, not just 0 and 1. Sometimes, for example, for the eye, the retina eye problems, they have like about 6 or 7 different type of sicknesses for the eye. So now we have 7 different classes. You may call them classes as well. So not just sick or not sick. No, even the sick part of the eye may be different level of sickness. Same thing with the diabetes. You can have different level, but nevertheless, they are discrete. So 1, 2, 3, 4, 5, even 10, 20 different classes, it is still discrete. Now, when you have a continuous output, let us say a pressure sensor that has a continuous temperature for the weather, a temperature for the weather, or maybe sugar level in the blood. This is where the regression part comes in, where you have a continuous data. We're not going to go into the regression for now. So our focus today is classical machine learning, supervised learning for the classification approach of the data. Now, the unsupervised learning, we don't have an output. We cannot directly classify, but this is a different area. I'm not too familiar with it, but the diagram here will show you some of, mostly will be the clustering part of the data, and that's what the researchers are interested in. Maybe next year or the year after that, maybe we'll educate ourselves with this extra topic. So I have the machine learning approach itself, and I have either supervised or unsupervised learning. I go into clustering or classification or regression based on my data has a discrete or continuous in nature as the output of the data. So this is just another presenting whatever I mentioned in writing. So the prediction part is that after understanding which one of my algorithms or which one of my classifiers can give me the best accuracy in the classification of my data, then I can say that I can, having an extra sample that is not part of my data, we can actually try to predict if this sample is healthy or not healthy, if we are talking about the heart disease problem, as we will exercise or express it in more details today. So what is this training, validation, and testing? As we will, when you get to start reading about machine learning publications, you will hear these interchangeable definitions in all published papers, actually. So this is my, if you see my mouse here, this is my data set. Data set is divided into training and testing. So this is usually 20% to 80%. Training itself, this is where the machine learning part comes. Training is you are trying to classify or predict or see if you can actually predict a case or a sample from your data set using a specific algorithm by this mechanism. So you have, from your training, you have 20% also for validation. You see, you divide the data. We don't do anything, by the way. We don't do anything. WEKA will be taking care of business for all. Actually, everything I'm going to mention is just a press of a button. This is the whole point of it. Cannot get any easier than this. But for you to be able to actually write something tangible, publishable, you need to understand the concept. So you can actually write your own write-up for the available result that you will gain using WEKA solution to get you the result. So the training part, the data will be divided into, we call it, well, they call it cross-validation, because they take one part of the data and try to predict the data itself, and then using certain algorithm, and then you do the testing on it, and then you average out over these. So usually the common approach is 10. You divide the data into 10 cross validation, 10 level of the data. And then every time they do the same, and they average it out over all the 10 cross validation to give you a specific accuracy, how well your algorithm, all the selected algorithm. So let us say we have 10 different algorithms. We talked today about maybe 6 or 7 of them, machine learning algorithms. Each one of them will give you different accuracy of predicting the data using the training set with the validation inside it and the testing set that is already divided by WEKA by itself. All right. And then you get some accuracy. You get some error, mean square error. You have certain statistical measures. Everything will be presented to you using WEKA. And then you try another algorithm, third algorithm, fourth algorithm. All the possible algorithms, maybe up to 6, 7, no more than, maybe 6 is fine. It's a good number. And then you do comparison between them, as we will see in a minute. And then you just draw a graphical representation of your finding, some write-up around it, and you have a paper. It's as easy, as simple as I am making it sound, as you will see by the end of this presentation, inshallah. So some of the main common machine learning algorithms that is being used almost by almost all of the bioinformatic machine learning published work is k nearest neighbor. This will use the Euclidean distance between 2 points. Naive Bayes, this is well known, use conditional probability between the two samples. So at the end, I have data. I have a scattered data, and I have, let us say, I have a binary class. So I have either healthy or not healthy. So I need to, I have the training, I have the validation, and I have the test. And I pick a point. And I want to predict or see if this point is in the healthy or not healthy. And then I will check if it is healthy or not healthy. Based on that, I will calculate the error of my approach as the algorithm I chose. Okay, so these are different methodologies. SGD, also well-known machine learning algorithm as well. So each one will have a different approach. And the literature is full of information about all of these approaches. And you can have also the decision trees, the random forest, random tree, one of the special decision tree is J48. So these are all possible classifiers or possible algorithms that I can select from Wiki directly to actually tell me how well it can predict certain data set. And for every data set, it's obvious. For every data set, it has a different distribution. So for every data set, all these algorithms can be applied, but for every data set, we'll have a different result. And usually, the paper will be written for a data set. So you select a data set, you introduce the data set, you run the data set with WEKA using all these different algorithms based on your selection. You don't have to use all of them. It's just for the sake of comparison. And then we just select which one will give me the best result in terms of least error or the higher accuracy. And that's it. Now, this is maybe not enough by itself, not enough to actually send the paper for like a good journal. What we do is, with the same data set, after presenting all the possible statistical parameters for that data set, for these classifiers, and we get all the result is there, maybe we want to do some extra effort. Extra effort is you select one or two of these classifiers. Now, some of these classifiers, as we will see in a minute, of course, all these classifiers are set as default in WEKA. But some of it, they have a different parameters. So some classifiers, it has up to 3 parameters. That is changeable parameters. So this is where the part of I can see how changing these parameters for specific classifier can reflect the performance of that classifier. So that's another extension. So you can say, okay, I want to do sensitivity analysis of a certain classifier for the same data and see how does it behave in terms of changing these parameters, one parameter at the time. So you change one parameter, you keep the rest as default, and you go from there, and then you have some extra result to show. Now, I mentioned at the beginning, instead of doing the 20 different tests for every walk-in to check for the heart disease, I can do it using only 6 or 7 tests instead of doing all the 20 tests. How can I do that? Well, you can do it with, now all these tests are features. They are features of this data set, which is the column. The heading of the column of all these data sets are features. Not all of them are relevant to the output. The outcome of the test, it's either healthy or not healthy. It needs 20 different attributes or features, but not all of them are relevant. So after getting 5,000 different samples, we can find out that certain test has no effect, no direct effect on the outcome or the output of these results. So we can also find these features for us and give us number of things actually. One of them can only give me the features that are directly contributing to the output. So that's feature selection or reduction, because I get rid of the non-needed features. Or it can give me all the feature with rank, which one contributing to the more to the output. It can rank them for me. So everything now I am mentioning, each one by itself is a section in a journal paper. is a section in a journal, and the required effort, or the needed effort for this, it's to get the result is actually not too much of effort needed. But the write-up, of course, now each person to other person will be different in terms of the required effort for the write-up, in terms of the introduction, background theory, introducing the data set itself, talking about this algorithm, talking about the statistical parameter you're going to use, and then presenting the findings, and then discussing your findings, and then that's the part that might take some effort from you. But nevertheless, I didn't get into the in-depth knowledge of these algorithms because I don't need to. I didn't get in-depth knowledge with the machine learning in general because I don't need to. Okay, so that's the whole idea of it is something doable, and it is manageable, and things can be tangible in terms of delivering nice results. So let us continue with the presentation. So these are some of the things, some statistical parameter that most of, if not all, of the published work in the classification of certain data in using machine learning algorithms discussed, with a relative absolute error, mean absolute error, Kappa statistic, area under curve. Each one will have different mathematical representation, different understanding. And we have seen them in one way or another in different courses or different areas because they are common statistical parameters. Something related to classifiers is the confusion matrix, which is if I pick a point and what are the percentages of, if it is a healthy sample, what are the percentages that I predicted as a healthy, and what are the percentages that I predicted as non-healthy? So that's a true positive and true negative. Or if it is an actual patient with a heart disease, also did I predict it as a non-healthy or predicted as an error as a healthy? So you have this concept of true positive, false negative, and true negative. That is also something research community in these topics are interested to see. Now, we mentioned a lot of things. We mentioned algorithms, we mentioned statistics, we mentioned certain things we look for. This is the parameter sensitivity. Also, we said some parameter or some classifiers, they have certain parameters, distinguish them from other classifiers. And these parameters, luckily, in WEKA are changeable. I can change the value of them, and I can look into the how the classifier behaving in terms of the finding the errors, or what is the calculated error, and the actual accuracy of that classifier. So some of them are more than others in terms of the number of parameters I can choose, and each one of them I can have a range of changes, and it'll give me different result. And this is something I can add as well into my findings. And this is the features. We said that we can do feature reduction or feature selection on it. So this is the WEKA part. It can either rank them for me or take away the one that are not relevant to my data. They don't do that. They do not contribute to the actual outcome of my classification of the specific data set. And there are some other manually done methods, also statistically, but not by WEKA. You can actually, I will show you also now in terms of, I have a large set of data. I look for the variance of every attribute, and then maybe exclude certain features with certain threshold in terms of the required variance that I will be looking for. And then this will reduce also number of features. So any feature that is not up to a certain variance, I will take it out. So I do a feature reduction on it in terms of reducing my actual test, if you want to call them. Test, if you want to call them, if we're talking about the heart disease problem. So everything we said so far, 95 0.9% can be given to you in terms of result using WEKA. So WEKA, let me just show you WEKA. So I have the website here. You can go to the website. I have it for you here as well. So this is WEKA website. You should just go and download it. Download it for Windows, for Mac, whatever you have. That's easy task. So that's WEKA. We download it, we install it on our PC, we open WEKA. This is WEKA. Most of our work today is only for the first WEKA Explorer. Of course, all the other ones, they have their own functionality, but the purpose of today's presentation is only starting with the first guy. So we'll click on Explorer. So this is my interface for WEKA. So there are a lot of buttons. We will go over most of them, if not all of them for today. But let me go back to the presentation, see what is this guy saying. So that's WEKA. Okay, we download WEKA. We install it on our PC. So that's a sample, as we will see as I will show you. So that's a sample. The good thing about this sample, let me make it bigger. So I run the data. I run the data on WEKA. And you see magically, WEKA will give me how long it takes to run this data. It says only 0.01 second. It gave me the 83.122% accuracy. And it gave me this 𝐶ABA statistic, mean absolute error. You see, all done by itself. Root, mean, square. So it depends on what are you interested in. What are you interested in to actually, well, basically for me, I'm interested with the accuracy. I'm interested with the 𝐶ABA, the mean, the root mean square error. And I'm interested in this part here, which is some people are precision, some of them in recall, some of them in F major. For me, I will be this here, the area under curve, the 0.9. We'll talk about it in a second. And this is the confusion matrix right there. You see, it gives me all the false positive, false negative, true positive, true negative. It's all there. So the matter of just uploading the data into WEKA, it's not, of course, uploading the data, it has certain steps we will discuss in a second. After uploading the data into WEKA, I will ask it to run the data. This is for one classifier, as we will see. So this is for one classifier, and this is the data given. And we have another classifier, will be different data. Another classifier will be different data. So now we have the concept of comparing the result between different classifiers. All right. So now this is a sample. This is the next one. This is an example of a sample that give me. I have 14. You see here, I have 14 features, or 14 attributes, or 14 tests per se. And now WEKA telling me only 3 of them are relevant. Only 3 of them are relevant. So you can imagine having a patient coming into a hospital, and you have to do 14 different tests to see if they have a certain disease. Now, but just by 3, maybe the age, the cholesterol, and this here, whatever is one of these, the instrument they have, it will be specified in the actual data introduction. When you get the data, all these parameters will be specified. So only 3 things. By only 3 things, I have a certain level. Maybe if this is my data, so I have 83% possibility to detect if this person is a healthy or non-healthy patient. Okay, so this is where we are going. How are we going around these terminologies? This is another approach that can rank the data for you. You see, these are all the data attributes or features, and WEKA will rank them for you based on their relevancy to the actual data or the actual algorithms that you are using. So each one of these results is, you can compare results between different classifiers, and this is actually a very respectable result publishable result. And there is a lot of similar approaches, similar papers published in the literature along these lines. Okay, so where we are now, if we go to the next slide. Okay, so data. There are tons of data on the internet. Tons of data, publicly available data. I don't need any permission. I don't need any extra effort or extra task to actually use the data. It's there. So the most two commonly used website, as you see in this presentation here, are the Google and the UCI. So I have a quick. So this is the Google. So you have, you see, you have like you see like Google search. This is all data. So you pick and choose whatever you are comfortable with. UCI has more data. You see? You see? You see? And each one of these, you click on it. So an example, it will give me description of the data, because of course, to publish a paper on a certain disease, I need to introduce the data. I don't just say, oh, I have this. No, this every site here from this here, the UCI, you click on any one of these, will give you all the description of the data, the information of the data, the attributes. Maybe make it bigger for you a bit. Who actually collected the data? You give them you give them credit for the people who collected the data. Of course, you have to write your own understanding of the data, but this is the main attributes. This here, for example, has 4 classes. You see? So you have 0, 1, 2, 3, based on whatever they have. Which data is this? What are we looking at? Dermatology. Okay, so this is dermatology. They have 4 different classes for some skin, maybe disease. And these are the tests that are done. Everything is clear for you here. You see? This is all the how you describe the data. I will show you now in terms of the Excel. And they will show you sometimes some relevant paper. You can also reference them that they use this data to do some published work. As you see, it is hot topic. As one sample, this is only one sample set. Okay, so the data usually is given to you in Excel, hopefully. Sometimes it is given to you as just text file. This will need an extra effort to convert it into Excel. Google has a lot of videos on that part. There is no issue. But the problem with WEKA, it's not a problem actually, but let us call it a challenge with WEKA. It doesn't take Excel. Well, it does, but it is a very lengthy approach. But it takes ARFF. They call it ARFF. And ARFF. And this here, I get you the website where you convert the Excel into ARFF. So this here a website, I have it on the presentation for you. So you have to convert it to ARFF so first you get it at Excel, you put it, you save it as CSV, and then you bring it to this website here, and you convert it. So let us try to do one file. So this here, these are the files I want to show you. So the things you need to pay attention to before you call in the file or try to convert the file. So sometimes you open the file like this one here. I have 2 headings. I have 1, 2. You see? And each one of these are actually, you see, each one is explaining to me what is this. Like here, level of pain. So 0, 1, 2, whatever they are. Either 0 or 1 or 2. The website telling me what is 0, what's 1, 1, 2. But it is telling me there is also 3. So because it says here, chest pain type, there are 4 values. As an example, the rest of them will have a similar approach. So when I want to convert this or use this in WEKA, I can only have one. I can only have one heading. It's just the way WEKA works, or the way this website works. So basically, it's easy. I just delete that row. I don't want it. So I delete the row. I keep it as one heading, and then I saved it here as Heart 4. I go to this website and I say, choose a file. I look for my file. This is my file here. It's Heart 4. Double click on it. After I made sure there is only one heading, huh? And then I will say submit. So now it show me all the features. It show me all the features. You see, it show me all the features in my. You see, these are the heading. So now I will say first row contains labels. I don't need the first row because this is just the naming of these attributes. The last one is the discrete value. I have yes or no, sick or healthy. 1, 2, 3, 4. Different level of diabetes, different level of skin cancer, different level of whatever. So it is automatic. I don't need to do anything with it. And then I say generate ARFF, generate. It will generate it for me. It will go into the bottom of the page or the downloaded. And then I'll just put it in my folder that I will be calling this data from WEKA. So now, just let me see. I don't want to miss anything for you. Where is the presentation now? Okay, so these are the steps, as easy as it gets. So find the data set from these websites, convert it to ARFF, use WEKA to perform the classification techniques, highlight the results. As we will see at the end, I will show you the results. Write the paper. And that's it. And then, of course, send the paper for publication. These are the steps. And believe me, I have an issue actually when I present an idea, I make it sound so easy and so simple. But believe me, this one, it is so easy and so simple to do. So let me show you just quickly. These are just some of my work. As I will see, all alhamdulillah, mashallah, single author. I put the effort on it about 2 years ago. I watch a lot of videos on WEKA on YouTube. I did a lot of background check on it. I read a lot of papers. But what I'm giving you now is just a conclusion, the basic, direct, quick summary of how these results were materialized. And alhamdulillah, all Q2, Q3, Q1 even. I have a Q1 paper, alhamdulillah, in PMC bioinformatic. And, oh no, not yet. Thank you. Okay. So let us go to the actual demo. So this is WEKA. We open WEKA. So now I have my file saved in a known location. Open the file. Well, look for the file in the, I think it is in the desktop. WEKA data for workshop. We will look now for the heart disease. This is heart 4 already saved before. Double click on it. So this is the first thing I see. This is the first thing I see on the when I open the data. Now, red and blue are healthy and non-healthy. Healthy and non-healthy. 1, 2, 3, 4, 5, 6, all these, the histogram are these on the left are all my attributes or features, if you want to call them features. Okay. So I can click on either one of them. So this is first one is the age. It was showing me the this is the age one, distributed the age. This is the male and female also. Whatever is this here, level of pain. So we don't want to bother with these. So this is my data. This is my data at the beginning. This here will tell me the minimum value for the age, 29 to 77, as an example. Also, but just to understand what is this, I have a mean value for the age. I have a standard deviation for the age. Okay, this is all good. I have here, it says I have 14 attributes, and I have 1025 samples. So this is just the basic information about my data. I'm not too interested in it because I just want to make sure that I can run WEKA on this data. Sometimes I don't have a sample here. Sometimes I get a data, interesting data. I will convert it and then I will open it with WEKA. It doesn't give me colors. It doesn't give me colors because it has a certain features. I will just I don't work with it because it's going to give me hard time. It will give result, but it's a very long way to actually get a reasonable result from it. So I will look for a certain set of data. First thing I open it. I have red and blue because this is a binary, sick or healthy. If it has more classes, it will show you more colors. So it means that it will work in WEKA. So that's what I will be looking for to start with. Okay. So now I want to go now to the actual machine learning algorithms that I want to run on this set of data to see what kind of result I can have. So I go to classify here at the top, and here is your classifier. You see, choose a classifier. Now, not just what I mentioned. The classifiers that I mentioned are the most commonly used classifier, but there are a lot of other classifiers. So this is the base one. Well, I'm interested in the naive Bay, the second one. This is the functions. I'm interested in the SGD, as I show you in the presentation. This is the lazy. I'm interested in the IBK, which is the key and KNN. So how would I know that? Because I worked with it a lot, and I read a lot about it, and watch a lot of videos about it. That's why I know these. But someone doesn't know WEKA, you can just follow these hints. You don't have to go all these classifiers. No. The meta, I never used it. This here, miscellaneous, I never used it. The rules, I use the decision table. I use the JREP. And the trees, I use the J48. I use random tree and random forest. Now, why am I using these? Because these are most of the things that other researchers are using. Not because I know why I'm using them. It's just because they give good results in terms of comparison between these classifiers. So I come to classifier. First one, naive Bay. I click on it. Now, it's already set to do 10-fold cross validation for me. I don't touch it. Just leave it. Okay. And then, of course, if usually the 80-20% of the dividing the data set between validation and testing and the actual training, this is set by default. If you don't like the default setting for whatever reason, you can change it here. Percentage split, whatever you want, but I don't bother with this. So I just leave it as is, as whatever the set default for the this classifier, naive Bay. Okay. Now I start 0.03 second. I get the data. I get the result. Nothing less, nothing more. This is one classifier. I'm interested again in the accuracy. I'm interested in the 𝐶𝐵 statistic, maybe. I'm interested in the error, maybe. I'm interested in the precision, the F measure, whatever you are interested in. I'm interested in the area under curve here, maybe, here. And I'm interested in the confusion matrix, maybe. Maybe you are not interested. Maybe you are interested only in the accuracy and the error and the time. This is all up to you. So I get a paper and pen and make a table, like this table here. This is as a quick example, maybe. And then just draw these. Let's just write these data. Maybe I will find, maybe this table is better. So we can consistent of what we're trying to say. So let's look at this table here. Okay. So I ran the naive Bay now, as you saw now. And then I will run the KNN. I will run the G48. I will show you now in a minute. Random forest, random tree, logistic regression, SGD, decision tree. Write down the data for accuracy, area under curve, mean error, root mean square error, and the time. And then just graph these. So graph these, and I have one graph. This is, for example, this is the graph using Excel. I'm not doing anything. I'm not using any uh, graphical website. No. This is the accuracy, for example. I just select the accuracy and see the changes of accuracy in certain x-axis. As an example, this is the comparison between many different graphs that I have. So each table will be, you see, for certain approach. I'm using certain approach. I have a certain data. And then I will just graph the graph, the presentation. Is it a line? Is it the histogram? Is it whatever you feel comfortable with to represent your data? So this is the naive Bayes, the first one. This is the data. I want to do another one. I want to see another classifier. So I choose another classifier. So I got a function here. Let us say I use the SGD start. So this is the result. So now I see here, I can, you see, I can flip between these two. They will give me the data I'm looking for per classifier. And then I will choose another one as you go. So let us say I use the in the rule, or maybe the trees. I choose maybe J48 as an example. J48. Start. And that's what I have. You see, J48 gave me 98% accuracy. SGD gave me 84% accuracy. Naive Bayes gave me 83%. This is a comparison. It's a valid, healthy comparison between these classifiers for a specific data set. And these are changing, of course, all the data at the bottom, the confusion matrix, the F measure, the errors, all changing. And as you saw in the here, this here, the data I try to represent the finding. Of course, whatever I did now in WEKA is this table here, which is fine. This gives me a comparison between these selected classifiers in terms of different statistical measures. Now I want to go into the, we talk about the parameter sensitivity. So let us say this SGD, I open this is the SGD. No, this is خلاص, run. This is done. So let us say I choose the SGD, which was in the rules, I think. No, the functions, sorry. So SGD. I click on the SGD now. Now you see the parameter. High batch size is 100. Epochs 500. Epsilon is 0.01. You see, lambda is 10 to the minus 4. You see, learning rate is 0.01. You see, I have 5 different parameters for only SGD. So I keep all of them fixed as a default, and maybe I change the epsilon, and I need to know what is epsilon. I will go do some search on it, read some papers on it. What is the epsilon? What is epoch? What is lambda for the SGD algorithm? And then I see changing this, what would the affect in terms of the output? And I run it with these changes. I just change it and run it again and again and again, and only for SGD. And I have another table. So here, for example, let me show you an example here. Random tree here. This is the example of a learning rate. Just make it big for you. You can see. So this is the learning rate. I changed the learning rate from 0, 0, 1, 0, 2, 0, 4, 0, 2. And I have different, you see, different accuracy, different area under curve, different errors, different time. And then I draw this. I have another graph. You see? So learning rate, this is the 1 over lambda, the learning rate. And you see, I hope the idea is clear, or I'm making it sound very simple, and it is simple. So I did that for the SGD. I have another table and another graph. I do that for the KNN as example. I choose KNN is in the lazy. This is IBK is the KNN. I click on it, and this is the K. 1, 2, 3, 4, 5. I change it. K, of course, the number of points needed for that classifier in order to merge them together to, or like 2 points close to each other or 3 points close to each other. And then it will give me different result. Will give me different accuracy, different error. So now I do a comparison. So this is in the literature called sensitivity analysis per algorithm. I don't have to do it for all of them. I just select one or two, and then I will do the change of parameters and see if there is any performance enhancement or degradation of the performance. And I just highlight the finding, and that's it. Okay. So these are now, we talk about the classification, different classifiers. We talk about the sensitivity analysis per classifier for some classifiers that they have certain parameters I can change. And now for the feature selection, I want WEKA to tell me the relevancy of these features. Are they all relevant? So I have, aside from the class, aside from the class, which is 14, I have 13 different attributes. Are they all relevant? I don't know. So I go to select attribute here. You see the one before the last one, and then I choose the third. So classifier subset evaluator. I choose the third set or the third select choice, and I will run the default. Okay. So let us see what we have here. It is running, I think. Select attributes. No, let us choose the first one. Start. Here you go. So this one, the first choice. One of them is for the attribute evaluation, one of them for the subset evaluation. Okay. So nevertheless, I will see which one will give me. So I have 14 there, but it's only selected 9 of them. What does this mean? It means that these 9 attributes have more relevant contribution to my classification. So what do I do now? Okay, I know that these are my attributes that they have more. Okay, now I go back to my data and I only use these attributes. Okay, it's a bit lengthy approach, but because I need to compare my selected attributes here with my full set of attributes. How would I do that? I have to do classification on it. So I do classification on the full as I did here. And then I will, oh, I see. Just 1 second, please. There's something here. Just 1 second, please. So I use the first one. And direction, okay. There is a button. Let me just, okay. Choose a method. Oh, that's fine. I'm sorry, just I'm trying to find one more button to tell me what is the classifier used. I know it is here. Forward, no. Contribute, subset. Oh, I'm sorry, I can't find it. So these are my, anyway, these are my features selected. I go back to the process and then I delete all the other ones. So I select the one I need, and then I can, like, if I select these, I can delete. You see here, remove. I can delete the one irrelevant, and then I can run the classification again with the one selected, and it will give me also different classification output already. So that's now we talked about the different classifiers. We here different classifiers used. We talked about feature selections. We talked about the sensitivity analysis per classifier. I can select one and then change the parameter of it. And now we have a lot of data to show. We have a lot of tables, a lot of graphs, a lot of diagrams to discuss. Now, if I can show you here one example, as an example here, the heart disease. This is the data we're working with. So this is a sample of published work, which is the heart disease, the data that I showed you. Just let us run here. Okay, so there are some write-up, of course, introduction, preparing the data, all that stuff. So you have a table, and then you have a graph. That's a lot of write-up. This is available. You can find it. And I highlight which one is the best classifier in terms of the accuracy. So you have a 99%, 97%, 98% as an example. And these are the statistics that I get out of WEKA. Okay. I reflect these results graphically. So the reader can actually see the changes. This is the confusion matrix. It was requested by this paper or by this journal. So as you see, this here PCF, one of the parameter for the J48. Change the parameter, you have different data, and then you reflect it in terms of, see the enhance of accuracy as an example with change of the PFC parameter as an example, changing of the kappa parameter as an example. You see, I play around a bit with the percentages of the training percentages, not just the default. And I did get some somewhat different results. Also, I can highlight them, you see? And that's what it is. That's exactly what it is. So this is the outcome. This is just me converting the what I'm trying to do in terms of direct classification or feature selection classification and the comparison between both of them to be able to find the result. And basically, that's it. This is the whole idea of the using machine learning algorithms, very moderate way, without going in depth into details, to actually find some reasonable result that is very respectably publishable. A lot of people are working in these areas. A lot of journals are publishing in similar approaches. Maybe not necessary in terms of comparison with classifiers or sensitivity analysis or feature selection, but nevertheless, you have you selected a certain bioinformatic data. Now, for example, now COVID-19, there is a lot of data on the internet, publicly available data. So you can select one of them and work around it in terms of whatever WEKA can offer you. WEKA can give you all the result. Now, how you're going to present the result for your readers, this is up to you. So this will be your personal own skills. Now, this is all what I have. I'm still worried about this button. There is a button here, I'm very sure, but I haven't used it for a little while. I hope I can classifier subset, choose forward. I don't know why I cannot find it. There is a button here to select which classifier I'm using to do the, maybe I have to go back to YouTube it, and maybe you have to do the same too. But anyway, this is what I have. I thank you all for your time. If you have any questions that I can answer now, you are more than welcome. If you, this is my email. If you want to send me an email, if you want to clarify something, I think Ida, the ladies at Ida Lab will share this presentation with the attendees. I'm not sure how it works. I suggest, if you allow me to suggest something, make a group or two or three members of whoever attended today. If you are working in the same department or you know each other, pick a data set. Pick a data set on the from the internet. Pick a data set and run these tests on it. Make a table, find some graphs, and Godspeed. If you guys want some guidance or some support, I don't mind. Send me an email. Even if you want me to help you with one of the papers to contribute together in a paper, I don't mind. But I suggest start making your own mistakes, do something with it, and inshallah, maybe in 2 or 3 weeks, you have something ready to be sent out. And there are a lot, like almost 40, 50 different journals that are very interested in bioinformatic, statistical approaches on data sets. And machine learning is a red flag for it. It's a very hot, catchy name for it. Classification, prediction, sensitivity analysis, all of these nice naming for these approaches are very hot topic. Now, on your Google now, just write classification bioinformatic. You will see tens of thousands of information and maybe thousands of published work on it. So why not have your name on one of these published papers? And if you select a certain data set, don't be afraid of the data set itself. Even if someone else publish work on it, it's the more the merrier. If they publish work on it, it means it is an interesting data set. Look at these published work quickly. Go over, browse them over for 4 or 5 quickly, 4 or 5 different papers that use your selected data set, and see what they're doing. Maybe they're doing in-depth analysis. Maybe they're doing something not related to WEKA. So here you have a chance to contribute to this data set using WEKA. Now, if someone from the audience expert in machine learning, they don't like WEKA. But WEKA is for us, for the ABCD type of contributors. But it's not something that, oh, this is very simple. How can I publish in it? No, I did, and I show you that I did, alhamdulillah. So don't underestimate the value of the delivered result, even though it is being done by an extra helping solution or software. But the way you present your finding is you. This is your work, and this is your contribution. And this is, believe me, it is a very hot, publishable work. And that's all what I have for today. And thank you all again for your attendance. And if you have anything, please go ahead.
Thanks all for being here, and thank you so much, Dr. Khalid, for this insightful and a very comprehensive talk and workshop, which is, I do believe, will be really beneficial to all the attendees. So now the platform is open for Q&A session. Please, if you have any questions. It's open to all the attendees. Please, if you have any question or comments or any feedback, please feel free to share with us.
So Dr. Tanzila, are you guys you will share the presentation with the audience, or how does it work?
Yes, doctor. We have our YouTube channel, YouTube channel. We will upload there, and once we will prepare their certificates of attendance, we will share with them the link as well. So,
very good. So I will share this PowerPoint with you too.
Yes, please.
So if
And the
someone, if
recording
someone
will be with us. Yes.
طيب.